So let's talk about tangent planes. So the blue over here is the graph of the function z equal to f of x and y. Here, point A is a point on that graph, point A and B and f of A and B, basically. And so what we want to do is we want to find the tangent plane at that point to the graph of the function. One thing to consider, function has to be differentiable for us to be able to find the tangent plane. That is that there should be basically a plane that best approximates z values around the point A and B if that's the linearization of the function f of x and y. And so that's the tangent plane, but knowing that tangent plane exists is one thing. Finding the equation of the tangent plane, if we know that it exists, is another thing. So let's assume that we know that the tangent plane exists here, and we try to find the equation of the tangent plane. To find the equation of the tangent plane, I already have the point A, right? Point A is given. What I need is two different vectors on the tangent plane. And two different non-parallel vectors on the tangent plane. And so that's my thing in this video. And what I want to do is I want to find a vector that is basically in direction x is when x increases, that vector appears. X increases only, and then another one that when y is increasing only, that vector appears. And by the way, those are going to be related to the partial derivatives of the function, basically. So let's look at this. This is the z. This is the x. The red one is the x direction, and let's basically find a plane that is parallel to x direction and goes through our basically point A. So in here, basically, the plane that is parallel to basically xz plane is going to be having a cross section on the graph of the function, which is right there, and then you can find the tangent vector on that cross section, and that tangent vector has to be on the tangent plane, because anything that is tangent to any curve going through A has to be on the tangent plane. So how do I find this vector that is in this direction? So let's see. Here, basically, we're cutting the function. We're making y value to be a constant b. And then we're finding this curve, and then we're finding the tangent to that curve. And therefore, for every step on this tangent, when x increases, then z has to increase by f sub x at A and B, basically. Because the y part is constant, then you can use the partial derivative. And then the similar thing happens when we find a plane that is parallel to xz plane. And then again, the vector that you find over there is going to be, if y increases by one step, z has to increase by f sub y of A and B, basically, on that vector. So the two vectors are given. Then you can watch the videos on how to find the equation of the normal vector, which is just crossing these two vectors, and then using this point to find the tangent plane. Again, these two vectors in x and y directions have to do with the partial derivatives, because we're basically finding the cross sections in x direction and in y direction, and that's it.